About myself, Vijay Lakshmi, having 12 years of teaching experience. My passion is mathematics, teaching mathematics that too. According to me, mathematics makes our life orderly and nurtures qualities such as power of reasoning, creativity, critical thinking, problem solving ability, and even effective communication skills. So these qualities we have to impart to our students also, right, teachers? So we have to impart these qualities to our students. For that, we have to set the learning outcomes. Not only setting the learning outcomes, that to be executed. Our children should acquire those learning outcomes. So how are we going to facilitate our teaching learning process? In that way, in that perspective, we are going to start our session. Yes, general aim and objectives of mathematics education. So mathematics education means the main concept, the main goal is mathematization of mind of children, enhancement of reasoning powers and visualization, developing problem solving skills, critical thinking in mathematics. In that, the main concept, the main goal of the mathematics education is mathematization. What is that mathematization? Mathematization means it refers to the act of interpreting or expressing mathematically. Otherwise, we can say state of being considered or explained mathematically. So children, any situation, they are able to interpret the concepts in terms of the mathematics, in terms of the numerals, in terms of the symbols, and satisfying the situation using with the help of the logic. So logic is the backbone of the mathematization. So for that, what we should do, we are the facilitators. So we have to help our students to bring those skills, not only just teaching the mathematical facts, mathematical concepts. We have to help the students enhance the skills such as utilizing the mathematics and seeing things in mathematical way. The teaching learning of mathematics stresses of developing the skill of mathematization. It is expected that children should expand the horizon of cognition by incorporating abilities that help them manage situations mathematically. Isn't it, teachers? So the main goal is mathematization, and this is our teachers' responsibility to bring those skills from our students. So now we have come to the main picture, that is the learning outcomes. So there are two concerns of the curriculum. That is, what can mathematics education do to engage the mind of every student and develop the students' inner resources to make them think critically and creatively. So children learn in a variety of ways: listening, reading, playing, interacting, and doing, isn't it? So this learning, what happens means they just think in the different way of giving the answer, different way of understanding, and more acute way of giving the answers. So this learning lead to change in their behavior, isn't it? And this change when observed and assessed. So note the point, the changes should be observed and assessed, and that we call as the learning outcome. Learning outcome is not just few words, okay, not just few action words. Those words we are able to observe and assess, and we should see the change in the behavior, and that should be assessed. That is called as a learning outcome. So a learning outcome is a measurable, observable, specific statement that clearly indicates what a student should know and be able to do as a result of learning. So in the process of learning that leads to the development of competences, it is continuous and spiral and not in the linear fashion. So learning happens in continuous way. So a learner happens to be in the state of learning, that is a process of learning. So learning outcomes are competences which learner continue to develop and improve. That is, the learning should be in the spiral form. You can see the spiral here. So in the grade, first initial grade, new content will be taken and revising that and mastering over the concept. Again, learning the new concept, revision, mastery should go in the spiral way and from the simpler to the difficulty level. That is called as the learning process, right? So to successfully bring those learning process and learning outcome from the students, what we have to do, how we have to take our classroom interactions. In that perspective, I'm going to give some illustrations in each and every point, right? So what are the competencies and skills that every child is expected to acquire in class 9 and 10? For that, how a teacher should transact the teaching learning process. Number one, what I have considered means in classroom interactions, we must provide opportunities for the students to achieve learning outcomes, right? So many of the times what we are doing means we want to complete the portions, isn't it? We want to complete the portions. Oh, NCRT, I have to do these many questions. I have RBS to complete. These many questions are there to do, right? Always we are thinking that, and many times we are not giving that much opportunities what actually they know. Isn't it, teachers? Am I right? Tell me. Tell
Yes,
me.
ma'am.
Right? Okay, you have this doubt, come later. Like that we are telling.
I agree with that, ma'am.
So we are not giving that opportunities, that is wrong. So we should give the opportunities. We have to see what the children are knowing. According to that, we have to proceed our work. The next is the emphasis on experimentation and exploration. So give some activities, hand-on activities. So from that, students will be able to understand it, and easily they can teach the remaining concepts if they understand it by giving the hands-on activities. So experimentation and exploration is very important. Then the next is the visualization. So children should visualize the concept, not only the figure or the graphs or something. Situation also, they should be able to visualize it. Okay, so I have told the 3 points. We have to give opportunities to the students and emphasis on experimentation and exploration, and activities in practical mathematics help students immensely in visualization. So let me give some illustration for these 3 points, then we'll come back to the presentation. All right. So are you able to see this? Right, my OneNote?
Yes, ma'am.
Yes.
Yes.
So we have to give the opportunities. So one such illustration I would like to give that happened in my class, recently happened. When I was doing the coordinate geometry concept, find the relation between x and y such that the point x comma y is equidistant from the other 2 points. So we would have been done like this, right? There is a point P. There are the 2 other points A and B, and those points are 3, 6 and minus 3, 4, and the point is equidistant from the points A and B. And after using the distance formula AP equal to BP and squaring on both sides, simplifying, the answer we got here is 3x plus y minus 5 equal to 0. And the children asked, ma'am, you told the point x comma y is equidistant, but here we got the linear equations in 2 variables. But linear equation in 2 variables means it has infinitely many points in that. Which point you are meaning here, ma'am? Which point you are telling it? Which point is equidistant? I told all the points on the line is the equidistant. All the points, how is it possible? All the points are equidistant from the 2 endpoints. Can anyone say how all the points are equidistant? What is this line called here? Teachers? There is a children doubt. Then I have given some leading question to help them. So all the points on this line that is equidistant from the 2 endpoints A and B. And the children, they just connected the triangles concept in the class 9. So if we have the line segment, when we draw the perpendicular bisector to the line segment, then all the points on the perpendicular bisector, which is equidistant from the endpoints. Using the congruence, we used to prove this. And here, children applied that and they told, so the point P, it lies on the perpendicular bisector of the line segment connecting A and B. So all the points on the perpendicular bisector are equidistant from the endpoints A and B. Therefore, the line is nothing but here perpendicular bisector of the line segment A and B. I haven't told anything about the perpendicular bisector. It's one of the important concepts in the class 10. Isn't it, teachers? One of the important concepts, this one. Need not tell about the perpendicular bisector. So they have to get it. So if we give the opportunity to them, surely we can bring the answers For that, just we have to give some leading question to them. When we give the proper leading questions, surely children should do excellent way. And they themselves told, yes, that line is the perpendicular bisector line. So all the points on that line, which is equidistant from the endpoints, right? Yes. And another situation I would like to give here, that is for the experimentation and the exploration. So experimentation means we have to do some hands-on activities to them. Right. So what I used to do means clinometer, right? Yes, teacher. So when we start the heights and distances, don't straight away go and tell it is the elevation, depression, like that line of sight. You take this clinometer and start the class, and we can easily engage the students, and children will be just watching you and they'll be observing you. So what we can do with the clinometer, just take it to the class and tell, see, today I'm going to find your height. I need not require any, any scale or measuring tape to find your height. So just by using this clinometer, I'm going to find the height. So like that, we have to hook up the students so that children will be very, very interesting. Wow, how is it possible without using the scale or measuring tape, finding the height? Yes, it is possible using the clinometer, and you just get the meter scale from the physics lab, place it and ask one of the students to stand, choose the tallest student, and you sit here, okay, and measure your height. And this is a 1 meter, right? And let be your height, that is your seated position height is some 75 centimeter or 0.75, like that, 0.75 meter. And use your clinometer and measure, see the top, right? See the top of the person, and ask the students to check the angle over here. Okay, they'll come forward and check the angle, right? And it is not a specific angle. Children know to tell the specific angle ratio, but here we can't express the specific angle. If we get some other angle, use the calculator to find the tan of the 28 degree something, right? So tan 28 degree, that is here, opposite by adjacent, you will get 1 into this perpendicular. Suppose that answer is 0.58. So 0.58 plus that 0.75, that is your height. So like that, we can interestingly bring the classroom. Isn't it, teacher? Have you ever done, please tell me, have you ever done like this in your heights and distances class? What way you proceed? Can you tell me? What way you used to proceed, please? So that I will also incorporate that to my class. I found it very interesting because we can easily hook up the students. Once I say I'm able to find your height without using the tape means, they just come forward and try to learn and engage in that activity. Can you tell me in what way you proceeded your heights and distances class? Yes, teachers? I would like to hear. Is this the same way? Please. Just 1 or 2 points I would like to hear, because your points I can incorporate in my classes. Please tell me. Please suggest some other way. Yes, Ramya ma'am, any other?
I didn't use this one clinometer to that, so this is a very new thing. Thanks for that. And we normally use like when we are introducing some heights and other things, we used to give some practical examples like why we are using these trigonometrical things. They might used to ask us a lot of time where I'm going to use this, why I'm going to measure this height, and what is the use of these things, ma'am. They used to ask. Then I was asking what is the height of the Himalayas. Everyone will tell within a short time, I'm 8848, like that. Then how you measured? Are we use that? Do we use that inch tape or anything else? Then how gonna we find that much height with a short time? So there we use these angles and other things. So practically, I used to explain some other things, but this thing is totally new to me, and thanks for that.
Yes, we can take this very, very simple thing. Clinometer, just we need the protractor and the straw to
Yeah.
fix to see that angle, okay, to see the position, right? Shanmugam sir, can you tell your views, what you used to do in the heights and distances class? Yes. Shanmugam sir, are you here? The same way we'll proceed. Aarti ma'am?
Yeah, ma'am. So far, I didn't use, ma'am. This is the
Okay.
first thing I'm going to handle 10th standard, ma'am. So
Okay. Okay.
definitely use this method. I'll introduce this method to children's.
Good, good.
Hope they will
Nice.
enjoy.
Okay, thank you. So we have seen one example for the giving the opportunity. Everything is interrelated, and we have seen one for the experimentation and the exploration. Then the visualization. So visualization, every time we can't show some picture, right? We can't handle with some picture. Sometimes if you explain it, children should relate it and they have to bring that. Okay. So one such example for the visualization I have taken the hollow hemisphere. To explain the hollow hemisphere or the spherical shell. Okay, what I used to do means I tell the children, come on, take the, just visualize the watermelon, spherical watermelon. Yes, just do the aspect of that, what you would see. Yes, ma'am, I can see the hemisphere. It is solid hemisphere, right? You just scoop out and take the red part in there. Take it away. And what is the remaining you're seeing? I'm seeing the hollow hemisphere, right? Okay, and I can pour the water. I can measure the capacity of the hollow hemisphere. Yes. Now you tell me, we have the watermelon, offcut watermelon. Yes. And in that, we scoop and taken out this red part, right? We scoop and taken out this red part. And it became the hollow hemisphere with some thickness. Now, could you tell me, just ask them to visualize, need not draw, ask them to visualize. Surely children will be telling that. Now ask them, can you find the total surface area of this hollow watermelon, hollow hemisphere, is the shape of the hemisphere. So children tell, I'm able to see the outer curved surface area. It's the green part. Yes, right. I can see the outer surface area, outer curved surface area of the hemisphere. So let me take capital R. So capital R be the radius of the outer and small r be the inner radius, and they immediately write, so outer curved surface area, which is the 2 pi r square. Then they can see the inner part, inner curve. So that is 2 pi small r square. Then they are able to see the ring part. So they have to visualize this. So ring part. So how will you find the area of the ring? We can ask and we can tell that, which is the pi
Capital R
r
minus small.
square minus pi small r square. Like that, we can relate with the some object. Just ask them to visualize. They will just do the wonders. Okay. Then spherical shell. Can you give some idea about the spherical shell? We have one problem, right? So spherical shell is melted and converting into the cylinder. What is the height of the cylinder? Conversion of the one shape to the other shape. Spherical shell. What we can relate it? Can you give some idea how you will relate spherical shell? What object you will take here? Yes, teachers. I would like to hear because.
You can have anything which they love the most. They use in a daily life, like any food, any chocolates, and they have so many things.
But
So
we have spherical shell, right? Spherical shell. Which object we can relate for spherical shell?
Laddu,
egg,
ma'am.
egg we
Laddu
can
is solid, right? We want the one is
egg
spherical shell.
egg
So
where
this is
egg,
solid
the
sphere.
egg is not actually spherical.
Coconut shell, ma'am.
Shell.
Coconut shell.
Coconut shell, right? Coconut. We can say take the spherical coconut, and we would like to find the volume of that white part. So we can give that example. Children will be able to understand for the spherical shell. Right? We'll move to the next part. So we have seen here giving the opportunity is foremost very important. Then experimentation and the visualization. So the next one we'll move here. Next one in that, yes, students should be able and competent to critically analyze various processes and create newer algorithms. So whatever we teach, and they should think in a different way. They should bring the newer algorithms. So for that, how we have to help. Then the next one, learners should familiar with the terms and the concepts. Yes, in the class 9 and 10, they have to be ready to write the terms and the concept and the usage of the symbols to represent the different concepts, and writing solutions and proofs. And the very, very important part here is justification. So justification is very important, and that will be imparted in the class 9 and 10. So not just telling true, false and giving the proof. Why are you telling that? Why you have given the statement and justification is so important. And then the next one is these students should integrate many concepts and skills that they have learned into a problem solving ability, right? So we have been doing the problem solving technique in our class 10, in class 9 and 10. So how to go about the problem solving ability, that we will see with a few illustrations. So now we have seen the three things, that is the bringing the newer algorithms, a newer way of doing, and then the next is the justification, and then next is the problem solving ability. Let us see these three concepts with some illustrations, right? That's my board. 1 minute. Yeah, here it is. Yeah. So the next is a newer algorithms. Just look at this question. Most of you handling the class 9 here. Are you able to identify this question? This is one of my sessions, higher order thinking skill session. The question here is the ABCD is a rhombus. EAFB is a straight line such that EA equals AB equals BF. And here to prove that the extension of ED and FC, it should produce and meet at right angles. That is, we have to prove that angle EGF is 90 degrees. So generally what we do means it is the rhombus. Rhombus, all sides are equal, opposite sides are parallel, diagonals bisect at 90 degrees. So to say that angle G is 90 degree, it is enough to prove that this OCGD, right? Are you able to see OCGD as a parallelogram? In parallelogram, opposite angles are equal. Therefore, angle G is 90 degree because in rhombus, diagonals bisect at 90 degrees. So angle COD is 90 degree. If we prove that DOCG as a parallelogram, then we can say opposite angles are equal. Then we can tell that angle G is equal to 90 degree. That is the concept. So what I did in my class means I told applying the midpoint theorem. So at last I was done midpoint theorem. So I just started with the midpoint theorem. I asked student, see here we have DBE triangle. Yes. So we have here DBE triangle. In this triangle, you can say A is the midpoint of EB because EA is equal to AB. So A is the midpoint of EB and O is the midpoint of DB because diagonals bisect each other. So O acts as the midpoint of this DB. So in the triangle DEB, A and O are the midpoints, and applying the midpoint theorem, we can say that AO is parallel to DE. Similarly, take the triangle CAF, and B is the midpoint of AF and O is the midpoint of AC, and we can tell that OB is parallel to FC. Then we can say here ED is parallel to AO, so the extension EG will be parallel to AC. So we can say DG is parallel to OC. And similarly, we can tell that DB is parallel to GF. Therefore, I can say this DO is parallel to GC. So both pairs of opposite sides are parallel. Therefore, it is a parallelogram. In that perspective, I have told. This is the usual way of doing. So what one of my students told means, I was really amazed that different way of approaching the question. So let me tell that. Why do you want to search of the triangles here? Already we have learned the concept. Why can't we use that, she told. So what she has told means, ma'am, AB is equal to CD because in rhombus all sides are equal. So we can say AB is equal to CD, and it is given that EA is equal to AB. So EA is equal to AB and EA is equal to DC, right? AB equal to DC, EA equal to AB. Therefore, I can say EA equal to CD. And in rhombus, opposite sides are parallel. Therefore, I can say EA is parallel to CD also. It becomes EACD becomes a parallelogram. Isn't it, ma'am? She told, yes, EACD is a parallelogram. Similarly, I can tell that DFCD. that is also a parallelogram. So now I told AEDC is a parallelogram, BFCD is a parallelogram. So because proving parallelogram is very, very simple to them, so they have told it. So in parallelogram, opposite sides are parallel. Therefore, I can say that EG is parallel to AC. Therefore, DG parallel to OC. Similarly, DP parallel to GF. Therefore, I can say DO parallel to GC. Both pairs of opposite sides are parallel. Therefore, we can say that DOCG is a parallelogram. In parallelogram, opposite angles are equal. Therefore, angle DOC 90 degree. So angle DGC is also equal to 90 degree. Some different way of proving. It seems to be very, very interesting. The 14 years girl rightly explained, and I was really amazed by seeing the girl's point of view. Then the next one is terms and concepts. So here we have to, they should be strong with the terms and the concepts, right? And giving the symbols to them, congruent symbol, similarity, perpendicular, parallel symbol, isn't it? And the justification is one of the important part in the class 9 and 10. So one such example I would like to share here, that is one of the questions in trigonometry, that is saying the true or false. Okay, so tan A is, the tan A is always greater than 1. Okay, true or false? Tan A, the ratio is always greater than 1. What do you think, teachers? We know it's not like that, right? It may be less than 1 or equal to 1 or greater than 1. Okay, so how the justification given here means the child told, ma'am, just take a right angle triangle. Okay, right angle triangle ABC, right angle at B. So here we have the theta. Okay, so when we find the tan A here, which is the opposite side by adjacent, here my opposite side BC is greater than the adjacent side AB. So for this condition, I'll get tan theta is greater than 1, because opposite by adjacent, I will get the improper fraction because opposite is greater than the adjacent here. I'll get the improper. So here my tan theta is greater than 1. Okay, suppose if I take the triangle, right angle triangle like this, that is my opposite side is smaller than the adjacent side, okay, with respect to the theta. So if I take like this, my BC is lesser than the AB. So at this point, I'll get the tan theta as lesser than 1. If I, namaste. Yes, ma'am. Anything you want to add on? Teachers, anything you would like to add on? Shall I proceed? Okay. So the other thing, how she justified me, suppose if my opposite side and the adjacent side both are equal, then my opposite side BC is equal to AB. BC is equal to AB. And this case, I'll get tan theta equal to 1. So we can't say always a tan value is greater than 1. It can be less than 1 or equal to 1 or greater than 1 also. So like this, the children justified by drawing the figures, right? Can you give some experience, some of your experience about the justification, teachers? Yes. About the justification, I am just telling my point of view, my experience. If you tell, I'll be very happy. Your in your class experience, how children justify the few concepts. You share that to me. Will you tell me at the last question answer session? Okay, so now we'll proceed the remaining part. So we have told about the justifying the things, and earlier we have spoken about the bringing the new way of doing, and the next is the justification, and the next is the problem solving ability, right? So most of the time we'll be doing the problem solving ability, problem solving method, isn't it, teachers? So I have taken one of the questions here for the problem solving ability. So problem solving ability has 4 things. One is the first understanding the problem. After understanding the problem, children should think and devise the plan, isn't it? So what way we have to proceed, what concept we have to apply to proceed this problem. Then after fixed it, they have to execute the plan. carry out the plan, doing the calculation and doing the working out part. And the last one, after arriving the solution, they have to look back and see whether they have got the correct result or not. So in this way, we have to proceed the problem solving technique. So I have taken one of the interesting questions from the linear equation. It is Ruhi travels 300 kilometers to her home, partly by train and partly by bus. She takes 4 hours if she travels 60 kilometers by train and the remaining by bus. Second case is if she travels 100 kilometers by train and the remaining by bus, she takes 10 minutes longer, find the speed of the train and the speed of the bus. So first, children should understand the question, read it, whatever the case is given, that should be noted it down. And here they have to find the speed of the train and the speed of the bus. So they have to allocate the variable for that. The speed of the train with some variable and speed of the bus with some variable with the units. And they have to write the condition. Here it is given the total hours, right? So time taken, we can write it as the distance by speed. So distance by speed, that knowledge children should be having to proceed this problem. So the first case, she travels 60 kilometers by train. So 60 is the distance covered and the speed is x kilometer per hour. This is the time taken to cover 60 kilometer by train. Next is 240 kilometer by bus. This is the time taken to cover 240 kilometer distance with the speed of y kilometer per hour. And the total time is the 4 hours. And similarly, children should bring the second equation. And here 100 kilometer distance with the speed of x kilometer per hour. And this is the time taken to cover the 100 kilometer distance with the speed of x kilometer per hour. And similarly, the second one gives the time taken by the bus to cover 200 kilometers with the speed of y kilometer per hour, and which is 10 minutes longer than the earlier. So 4 plus 10 by 60. So this is the equation, and these children will be solving. And the answer here is the 80 kilometer per hour and 60 kilometer per hour. The speed of the train is 60 kilometer per hour and the bus be 80 kilometer per hour. So first, understanding the question in the problem solving ability, understanding the problem, and then think and devise what to be done there, what kind of the concept to be taken to solve the problem. And once decided, carry out the solution part, working out the equation. And then the last one, look back. Look back is very, very important. Here, 60 kilometer is the speed of the train and 80 kilometer per hour is the speed of the bus. And children should verify the result by applying here. So 60 is the distance covered by train and the speed here is the 60 kilometer per hour. So which is 1 hour time taken to cover the distance 60 kilometer by train. Then 240 kilometer is the distance covered by bus and the speed here we got 80. So 240 by 80, which is 3 hours. So 1 plus 3, 4 hours, it is tallied. Similarly, it has to work with the second equation also, right? So one of the important technique, problem solving ability that we have seen. So next we'll move to the remaining part. So I've come to the presentation. The next one is the reasoning, mathematical reasoning, analyzing and constructing the process involved in mathematical reasoning. And one of the important aims of the mathematics education also, mathematical reasoning. Then development of critical thinking. This gives the higher order thinking procedure. Then the last one, establishing the linkages between mathematics and daily life experiences. Yes, children will play on this. They'll do any number of the things, but we have to validate their experiences. So the next three we are going to see, there is a mathematical reasoning, critical thinking, and daily life experiences. Right? Okay. Are you here with me? Are you
Yeah,
here?
ma'am.
Yes,
Yeah,
ma'am.
ma'am.
All right. Okay. Yes. So for the reasoning, I have taken this example. So recently, I have gone through this. That is, my students love this part. That is, in the reasoning. Reasoning means mathematical reasoning enables children to arrive at solutions, judgments, and conclusions after manipulating the facts involved in the problems. So there are two types of reasoning. One is the inductive reasoning. The other one is the deductive reasoning. Inductive reasoning means it starts from the concrete examples, okay, giving small examples and then go to the generalized form. Whereas deductive reasoning is quite opposite to the inductive. It starts from the general, okay, giving some derivation and using the derivation, applying the concept and applying the concept and bringing the answer. So inductive reasoning tells that concrete to abstract, whereas deductive reasoning tells us general to particular. So one of the things is I have taken the example from the coordinate geometry. So to derive the formula, distance formula, generally what we used to do, we say just one simple example. So see, there's a town B and town B is 36 kilometer east of town A and 15 kilometer north of town B. Can you find the distance between the two towns A and B? So here it forms a right angle triangle, and by using the Pythagoras concept, we can find the hypotenuse area, which is 39 kilometer distance. First, we'll start with a simple example. Then we'll just move to the other thing. That is, if we take the points on the coordinate axis. So one point on the x-axis, A, that is 4, 0. The other point on the y-axis, which is 0, 3. Right. Now you find the distance between AC, and this is also very simple to the students. They say, so O to A, the distance is 4 units, and O to C, the distance 3 units. Therefore, hypotenuse, AC is a hypotenuse, which is the 5 units. So easily they will say. Similarly, if we take the other point B and D, if the points are on the coordinate axis, children would be easily find what is the distance between those 2 points. Right. And the next thing is, suppose if those points are on the any of the quadrants. Okay, so here P and Q, both the points are on the first quadrant. Then how will you take it? Means children should analyze until we need one right angle triangle. So right angle triangle to be formed to find the distance between the P and Q. So how the triangle should be formed? So we have to drop the perpendicular P to the x-axis, Q to the x-axis, and joining P to T, which is perpendicular to the QS. So right angle triangle is formed here, right? And applying the Pythagoras property, we can find the distance PQ. And children should think analytically, what would happen if the points on the 2 other quadrants? So then also we have to tell that even if the points are on the 2 other quadrants, right angle triangle should be formed. So children, they have to make the right angle triangle. So we have the points P and Q. P point in the first quadrant, Q point in the third quadrant. And the task here is to find the distance between P and Q. And children, they have to form the right angle triangle by drawing the perpendiculars, and the meeting point is T. So again, by applying the Pythagoras theorem, children are able to find the PQ distance. Like that, we will be giving small concrete examples, and then we'll move to the abstract, that is the deriving the distance formula in general way. So taking the 2 points P and Q, the point P is x1, y1, and point Q is x2, y2. So children will be able to find the PT distance, which is x2 minus x1, and QT distance as y2 minus y1. Therefore, the distance between P and Q, applying the Pythagoras property, which is base square plus perpendicular square, right? So x2 minus x1 the whole square plus y2 minus y1 the whole square. So like that, giving some examples and bringing to the general formula, this we call as an inductive reasoning, right? And then we have deductive reasoning. Deductive reasoning. So we'll be telling the general idea about that. It may be the derivation of the formula for surface area and volume. And after giving the formula, applying the formula and bringing the answers for any situation. And that we call as a deductive reasoning. So here I have taken the one such example. This is our NCERT question. It is about finding the shadow of the girl. So a girl of height 90 centimeter is walking away from the base of the lamp post at a speed of 1.2 meter per second. If the lamp is 3.6 meter above the ground, find the length of a shadow after 4 seconds. Could you tell me how I am telling this question comes under deductive reasoning? So children is giving the reasoning right here. Could you tell me how it comes under the deductive reasoning? Yes, teachers. So here we would have been taught the difference similarity criteria, right? Angle, angle. What is mean by angle? Yes.
Yes, ma'am. From general to particular means first, by looking at the triangle itself, they know the general concept of these things. From that, they will understand the questions. Then they will particularize the thing what they are going to do. So from general analysis to particular towards they will go. So that only it comes under the deductive analysis.
So they know very well what is the angle angle similarity, right? RHS similarity, AAA similarity, SSS similarity would have been taught by using the theorem proof format. Then that general concept applied here and bringing the particular situation answer. So I'm calling this as a deductive reasoning. So here the two triangles form the two triangle CDE and the bigger triangle AB. The both triangles are similar under angle angle similarity criteria. So if the triangles are similar, then we can say the corresponding sides are proportional by CPST. We can say the corresponding side proportional. Then applying the ratios, equating it, we found the answer 1.6 meter length is the shadow length. Okay, so here this is the reasoning part. So children should understand it and they reason out why we are using this concept. So here the application is applying the AA similarity criteria and bringing the answer, isn't it? So we have seen here the first one, that is the problem solving ability. The next is the reasoning out. We have seen the two types of the reasoning, inductive reasoning and deductive reasoning. And the examples have given one with the coordinate geometry, the other with this applying the similarity concept and bringing the answer. The next one is critical thinking. My lovable concept, this one, critical thinking. Critical thinking is defined as meaningful, unbiased decisions or judgments based on the use of interpretations, analysis, evaluation, inferences, and explanations of information as it relates to the evidence applied to the specific discipline. So judgments and decisions based on one's own experience or claiming one's own decision with supporting proof. Okay, this I would like to give as one of the examples for the critical thinking. So this I experienced in my class. I would like to share with you all. And please give your experience. I would like to know how you have done this concepts. There are any number of the concepts, please share with us. So when I was dealing with this AP, finding the missing terms. Okay, the first question I have taught like this. See children, the first term is A and second term I don't know, this A2 and the third term is A3 which is 26. So A is 2 and A3 is 26. So what is A3? A3 we can write as A plus 2D. A plus 2D equals 26 and apply A as 2. So 2 plus 2D equals 26. 2D equals 24. D equals 12. So we found the common difference 12. Then what is A2? A2 is 2 plus 12, 24 and 24, sorry, 2 plus 12, 14. 14 plus 12 is 26, isn't it? Okay, yes, understood. So why can't we think in the other way? Yes, what is the thinking? So 2, 26, I want to find the midterm here because we know the gap between the first term and second term is same as the gap between the second term and third term, right? So the A plus B is second term and again A plus D is the third term. So the common difference is same here and the gap is same here. I use the word gap here. Okay, and this second term acts as the midpoint. So we can find by using the mean of the first and the third term. We usually do this, right? So I told 2 plus 26, which is equal to
28. 28 by 2.
28 by 2, that gives it 14. Like that we can do it. Or we can tell that we have used the mean here, or we can say the gap is same. So let me take that A to be X. Then I can say X minus 2, A2 minus A1 is equal to A3 minus A2, right? So 26 minus X. So like that we can equate and we can bring the answer X equal to 14. I have told these ways. And I worked the second problem, third problem. When I was working with the fourth problem, the few girls, they just struck the point gap. So gap they kept in their mind, and I told here the same way, algebraic way only I have taught this. So okay, A equal to minus 4 students, And second term, we don't know. Third, we don't know. Fourth, we don't know. Fifth, we don't know. Sixth term, A6 is 6. And using the algebraic way, I have found the in-between 4 terms. And what one of the students told me, ma'am, why we have to do with the algebraic way? It is just the, mentally we can do it. How you'll be doing? -4 and 6. See the distance between -4 and 6. The distance here is the 10. -4 to 6, the distance is 10. Right now, how many gaps are there? 1, 2, 3, 4, 5. 5 gaps. Divide by 5. Yes, 2. 2 is the common difference. Add 2 and bring the answer. -4 plus 2, -2. -2 plus 2, 0. 0 plus 2, 2. 2 plus 2, 4. 4 plus 2, 6. Why you want to go this and all? Just it's a applying knowledge only, no. Why you want to just see the gap, find the distance. Not only this problem, what she did means everywhere, wherever she wants to find something, she'll just see the gap. Okay, she sees the distances and divide with the gap, and she will get the common difference, add and bring it. So in that perspective, she handled this problem. And the fifth question also, what she did means she didn't take that A2 equals 38. A7 equals -22 and solving the equation. What she has done means we don't know A, first term we don't know. A2 is 38 and A3, A4, A5, A6 is -22. So need not go for any algebraic way. We know 38, we know -22. So we can find the midterm here, right? So A4 is the midterm of A2 and A6. Find A4. Then after finding the A4, A3 is the midterm of A2 and A4. Add and divide by 2, we will be getting the A3. And similarly, A5, we can get it by, what we can do to get it A5?
A4, the midpoint between A4 and A6.
Yes. A4 plus A6 divide by 2 and she got it A5. Then we know the common difference and she subtracted common difference from A2, she got it. So like that, using the midterm formula and the gaps, easily she found the answer, and it seems to be the different way of thinking. I just found this very, very interesting. Okay, every time we used to do with the algebraic way of bringing the answer, and this I found it as very, very interesting. Right? So now we have seen few things. Let us just recall. And we have justification of the things and problem solving ability, mathematical reasoning, critical thinking, daily life experiences. Daily life experiences that we know every day we are dealing with the daily life experiences in mathematics is mostly linking with the daily life experiences. Then the next one is the learning outcomes of mathematics to be seen as integrated with the other topics like numbers related to geometry. So when we teach the real numbers, we just represent the real numbers in number line. So we are bringing geometry to the real number concept. It is the identification, it is representation of the irrational numbers in the number line. Is it students? That is representing the geometry on the real number. Similarly, talking about the algebra in the coordinate geometry concept, because coordinate geometry acts as the tool of the algebra. So like that, we have to interlink the concepts. Okay, not only interlinking the topics in mathematics, we should also interlink the other subjects into our mathematics. So we have to integrate other subjects, not only science, social science, it may be anything. Okay, even what we can say, economics, we can bring it into subject, right? So we can bring the other subjects into our mathematical concept, and later problem solving. See one such example for this, and we'll move to the next. Right. So mathematics and daily life experiences. Could you give some example, teachers? I'll be very happy. Take the last 2 points. That one is the mathematics and daily life experiences. If you give some examples, I'd be happy. The next one is the integration of mathematics with other subjects. Right? Yes, one examples here. Other teachers? So we have some 10 minutes of time. We'll explore this, and we have to do a few other things also.
Now we are, yeah, ma'am. In daily life, the people, that means our people nowadays are too much connected with gadgets nowadays. Like now we
Yes.
are using mobile and laptop and we are using the network things, and they might say, ma'am, in online classes it's the data is drying out in a very fast manner, ma'am. So how much we are using, there is certain calculations for that. How much, what is the video quality you are using? If you are not using the video, there will be the progression will be very slow. If you are using the video, it will be very fast. So they were
Proportion
telling,
concept.
they were going in the geometric progression, not in a arithmetic way, ma'am, like that they used to say. So it happens in a day our life, and we are using each and every minute in our life. We are using max anyway.
Right, right, right. Good. Nice to hear this. Okay. Then the integration of the mathematics and other subjects. So I have taken the one such example, mathematics and social sciences. Okay, in geography, finding the height of the mountains, knowledge about the rivers, longitude and the latitude, right? So when we talk about the coordinate geometry, the main purpose is locating the place. So locating the place means we need the two reference line to locate the place. So we can tell to the students how that Ola and the Swiggy people exactly finding our addresses, right? They are pinpointing our address. How they are able to do it by using the latitude and the longitude imaginary lines. So those two lines acts as the reference line, and using the reference only, they are able to find that exact location. So like that, we can give some interesting example. So we'll go to the next slide. So up to this, we have seen how we have to take our teaching learning process. So we have to give opportunities. We have to emphasis on experimentation, exploration, visualization, bringing the newer algorithms, justification skill, problem solving ability, mathematical reasoning, critical thinking, daily life experiences, and learning outcomes. You should integrate with the other topics in mathematics, not only in mathematics topics, and also with the other subjects. That only we are dealing in the case study questions, right? In case study questions, mostly we'll take the general topics using the other subjects. From that, we relate and we give the questions, right? So the next, learning objectives, learning outcomes, learning indicators. So keep on, we're talking about the learning outcomes. Earlier, we used to set the learning objectives some 3-4 years back. From 2019 only, CBSE is telling we have to write the learning outcomes in a lesson plan. Earlier, we used to write the column learning objectives. So learning objectives is just to say what is the goal set by the teacher, provides a structure to the teaching and learning process. Students and teachers know what they are striving for. We'll write to know this concept, to understand, right? To understand, to appreciate. So to appreciate the Sridharacharya quadratic equation formula, right? We used to write like this, but these are all the objectives. This knowing, understanding, appreciating, learning, these things are not measurable. Are we able to measure or assess the appreciation things? Are we able to measure? No, we can't measure. Children, children is appreciating the concept of quadratic equation formula, derived quadratic equation formula, Sridharacharya concept. So the appreciation things, understanding things, it is not measurable. Okay, so that course we shifted to the objectives to the learning outcomes. So learning outcomes tells about the learning actions, what the children will do after understanding this concept. So they are able to classify, evaluate, compute, right? And creating the new object, isn't it? Creating the new model and finding the total surface area and the volume of the new combination of the solids. Okay, so those things we are able to observable and it is measurable. We are able to observe and measure those things. And it indicates how the learning will be visible. So by learning outcomes means it should be visible. How they have learned, it should be visible. That's what we have said the learning outcomes. And learning indicator means what the evidences that they are showing by the students. That is that we call as evidences of learning. The children, they are creating their projects. They are doing the mind mapping. They are creating the chart work, right? And the art integration project using the Kashmir, Jammu and Kashmir, they're creating the art integration project, isn't it? Using the mathematical concept, they are creating the art integration project by using some other art forms. So those are the evidences to us, and that acts as the indicators. So pointers which indicates the extension of the learning and its quality, those we call as the learning indicators. So now to close the gap in the achievement of learning outcomes, classroom transactions will shift towards the competency-based learning and education, right? So learning outcome focused delivery, our class delivery should be based on the learning outcomes. Then activity-based learning, interactive teaching. So it should be over the interaction. So ask the students, they will give the n number of examples, okay? And many children having some doubts in the concept, if we just clear the doubts, from that we can take the class, from that we can start our class. It will be really very interesting. So our class should be the interactive manner and always focus on the development of the higher order skills. Each and every concept we teach, in that there should be some higher order skills to satisfy the toppers and the self-paced learning. The next is the ongoing assessments and feedback. So we can give small assessment based on our topic. We can conduct small quiz or a minuscule test to be given, or the oral test, formula test, concept mapping. Like that, we can give ongoing assessment and we can get the feedback. According to the feedback, we can proceed our classes. Real world relevance of the assessment. So always, whenever we conduct assessment, just don't ask the question, solve it, solve the following. Okay, find the answer, find the value. Instead of doing that, give some real world relevance. That kind of the assessment can be imparted. Then higher order skills based assessment. Assessment not only just the basic questions, it should be touch the higher order level concept also. Then synoptic and interdisciplinary assessment. We have seen the learning outcome also. When we are setting the learning outcome, we have to touch the other subject also, so that we can bring the interest and we can engage the students in mathematical concepts. Then the questions, whatever we are setting, there should be some validity and reliability of the particular assessment, right? So these are the important things we have to emphasize during the teaching and learning process. So learning outcome, that should be focused when we are transacting our lessons, and activity-based learning and interactive teaching is very important. Higher order skills, self-paced learning. Sometimes we can convert our classroom to the flipped classroom, right? So we can give concepts, we can tell these are the things you have to do it, and let them give some seminar based on that. It will be very interesting. And now many portions are deleted, isn't it, teachers? In the class 10, if you see, a lot of portions are deleted for this academic year, isn't it, teachers? Right? Have you seen the curriculum? Have you seen the curriculum of the class 10?
But even if it is omitted,
Yes.
it is better we introduce certain things which are needed for higher classes.
Even though it is deleted,
It's better you go in to give some knowledge about it, if not into the depth of it.
yes,
Let us
yes,
give them some idea about it. Don't delete
Yes,
anything just like that, because they will suffer when they go for higher classes.
exactly, ma'am, exactly. So even though
Please,
those portions are
please,
deleted,
slightly here and there, you can touch each and every concept. Don't miss
right.
anything.
Absolutely right, absolutely. So deleted, we have many portions deleted, but we have to touch those concepts. Otherwise, higher classes, they will really find it very, very difficult. Then usually, this is a way we just write the learning outcomes from each and every chapter. So quickly, we'll see that what are the learning outcomes we usually write in the different chapters, right? So in number system, in class 9, children should able to visualize. See the word use visualize. They have to visualize the various types of the numbers which constitute the real number system, applies the logical reasoning. So in class 6 onwards, they are proving the properties of the different number system. So class 6, they deal with the whole numbers, properties of the whole numbers they'll do. Class 7 with the integers, class 8 with the rational numbers, and class 9 with the irrational numbers, right? So like that, we have to make them to understand it is the continuous process. So what you are doing, the closure property, distributive property, associative property, commutative property in the class 6 with the whole numbers, that we are just doing understanding, verifying those properties with the other number system. Like that, we have to make them to understand the things, then observe the properties of different types of the numbers based on the knowledge of numbers gained in the earlier class. And class 10, generalizes the properties of numbers and relations. And based on that, understanding Euclid division algorithm, fundamental theorem of arithmetic, and applies them to solve the problems related to the real life context. Then we have algebra. In algebra, identifying or classifying the polynomials among algebraic expressions and factorizing them by applying the appropriate algebraic identities and relating the algebraic and the graphical representation of the linear equation in one or two variables. And everywhere we can see applying the concepts in the daily life situations here. Applying the concepts in the daily life situations, it's foremost important in the class 9 and 10 level, not only class 9 and 10, in all the grades. So whatever the concepts they are learning, that should be implicated in the daily life situations. Then geometry. In the geometry, identifying the similarities in the class 9, identify similarities and differences. Similarities and differences among the different geometrical shapes, deriving the proof, constructing the geometrical shapes like bisectors of the line segment, angles, triangles under given conditions. Then class 10 works out ways to differentiate between the congruence and similarities and establishes properties for similarity of two triangles logically using different geometric criteria, BPT, deriving the proof, constructing the triangles, pair of tangents, right? The next one, statistics and probability, one of the interesting concepts and completely different, the probability compared to the other chapters, right? So that we are going to discuss in one of the sessions. Then here identifies and classifies the, again, see the daily life situations in which mean, median, and mode can be used, and analyzing the data by representing it in the different forms, different tabular form, representing the data through bar graph, histogram, frequency polygon, calculating the empirical probability and experimental, the empirical probability and the classical probability in the class 10, right? So calculating the mean, median, mode of the different set. Here the class 10 with the grouped data and everything relating to the real life contest. Then mensuration, one of the interesting concepts, the mensuration. So class 9 deal with the individual objects, whereas the class 10 deal with the combination of the objects. Yes. And the next, coordinate geometry. Coordinate geometry. When we talk about the coordinate geometry, please tell about the mathematician René Descartes, why it has come the Cartesian plane. So to honor the mathematician René Descartes, we have taken the plane, we have named the plane as a Cartesian plane. So Cart come from the mathematician named René Descartes. Okay, so please tell how he got that idea about the coordinate geometry while he locating the point when he was lying on the bed. He would like to locate the fan on the ceiling. So how he located that fan on the ceiling? So that way only he developed the coordinate geometry concept. So if you give those things, and really we can engage the children, and children, they love mathematics when we give the facts like this. Then deriving the formula is one of the important thing in the class 10 coordinate geometry concept, and in trigonometry, determining the trigonometric ratios and applying in the real life concept. Then the last one, that's it, we have done.